Good morning everybody. Today I am going to start the video lecture 3 and I have already given 2 lectures in the previous classes, and in previous 2 video I have discussed about probability, mean energy as well as partition function. So that is why I request all of you to watch the video from starting point to ending point. Okay, if you see the video continuously, then you can understand the basic fundamental thermodynamical parameter. For example, probability, mean energy, partition function, you can easily understand. And if you understand this part, then the rest of the statistical phenomena and as well as specific theory, mean energy, free energy, enthalpy, then you can easily understand. No need to memorize, just try to remember original mathematical equation. And today in today's class I am going to give you, first of all I want to give you 1 or 2 numerical problem based on partition function, mean energy and all this, and after that we will move to thermodynamical parameter, how we can remember the thermodynamical parameter without going to the detail in the example, details that are written in the books. Okay, first of all I will write the mean energy again, because mean energy, okay, mean energy of statistical system. I have already given you the mean energy formula. You can write E also, no problem. E also, mean energy E is equal to sum of ER e to the power minus beta ER and sum of e to the power minus beta ER. This is for non-degenerate system. Okay, and one thing I want to share you, in quantum mechanics, mean value x equal to wave function x in the middle portion. This is a bracket notation. Okay, wave function, this is the probability. Okay, suppose if I want to mean value of x square, then same formula will be remain same. Only x square you have to change. Okay, similarly, suppose if I take the mean value of x in statistics, you see the statistics, if I take the any mean value of x, suppose x value, that is in quantum mechanics. In statistics, if I take the mean value e to the power minus beta ER, so it will be xr e to the power minus beta ER. Okay, and don't think that this is the expression is valid only for energy. This expression is valid for any thermodynamical mean parameter. If you want to evaluate mean energy, mean momentum in statistical framework, then you have to use this formula. Only if it is E, that is why we are putting E. Suppose if it is X, it will be X. If it is entropy, it will be entropy. Rest of the portion will remain same. Okay. And another thing in quantum mechanics, in quantum mechanical view, suppose expectation value, finally what we are getting, expectation value we are getting ANPN probability. Suppose if I put E, then in quantum mechanics, then it will be EN. It will be P, then it will be PN. It will be, suppose A is suppose arbitrary parameter, so it will be ASN. Okay, so it will change according to the operator. Similarly here, if I energy, then it will be ER. Suppose if I take mean energy square, okay, mean energy square, then it will be, formula will be remain same, similar to quantum mechanics. It will be ER squared e to the power minus beta ER. Okay, if it is squared, then it will be squared. If it is cubed, then it will be cubed. Okay, if it is entropy, then it will be entropy. If it is entropy squared, then it will be entropy squared. Rest of the portion will remain same. Similarly in quantum mechanics. So if you forget, then you just try to remember the quantum mechanical formula. Then it will help you to understand the statistical phenomena also. Okay. So if this is the mean energy formula, in question, a Coulomb interaction, when you talk about Coulomb interaction and solid, then there is a question comes in exam. Then question is given like that: if the Hamiltonian of the system is sin of plus half m q dot square plus square q square. phonon interaction in crystal. This problem is related to phonon interaction in crystal. I will discuss the Debye and Einstein theory in statistics. Okay, instead of condensed matter physics. Then you can easily understand all the passive heat theory, internal energy, power of internal energy. I will discuss in statistics also. It will help you understand both statistics and condensed matter at the same time. Okay, so if you see this is the Hamiltonian, then what is the energy? Energy we can calculate. One thing you remember why I am writing this here. This is the perturbation theory. Okay, why I am En, I am putting x, but here I am telling x will be x, x square will be x square, but here I am putting x because this is due to fact that we have remember this equation equal to E phi, right? This postulate number 4 in quantum mechanics, I think you already know. So if I take both sides bra, then we have to take both sides. Okay. Now E is the eigenvalue. It's a numerical value. Suppose 5, 6, 7, 8. So you cannot take the eigenvalue mean of eigenvalue. So E is constant. So it will be come out. So psi, and it will be 1. So E. So that is why, that means eigenvalue we can calculate the expectation of. Okay. This is why in quantum mechanics E expectation value, E is the eigenvalue of energy, and eigenvalue which is known as the energy eigenvalue, and expectation value of Hamiltonian. This is the first order perturbation, but you may ask the why denominator part is missing. Okay, because this is a normalized wave function. That is why the normalized wave function means probability is 1. That is why I am not writing here. Okay. So in this case, if I take this is a harmonic oscillator. Okay, what is the energy? If we put this value here using perturbation theory, I am not going to give the detailed theory of perturbation here because I am talking about statistics. So it will give psi naught plus energy of the Hamiltonian operator. Harmonic oscillator. This is the harmonic oscillator. This is the energy of the harmonic oscillator. In this case, how can you calculate the mean energy? Suppose we have used the blackbody radiation calculation. So I remove this part due to space limitation. I will write again. Okay, this is the energy. Finally I got the energy. This is psi naught plus half. N plus half is cos omega. This question comes in a net exam. This is the energy of harmonic oscillator, and phi naught is the energy, 0 point energy. Suppose this energy is due to internal interaction of atom, and this is the harmonic oscillator energy, one-dimensional harmonic oscillator. Okay, and how can you calculate mean energy? Okay, you can simplify in exam. It is written like this: psi naught plus half, because it is alpha and is cos omega. In exam it is maybe like this. Suppose question is like that: if the energy of a system is alpha plus n is cos omega, then what is the mean energy of the system? It may be like this, or you can say alpha plus n beta. N b, suppose b is constant, not beta. So alpha is n beta. How can you calculate the mean energy? So it is very simple. You just remember that I have already shown you the mean energy, how to calculate in blackbody radiation. Here also statistics also. This is the formula: e to the power minus beta er e to the power minus beta er. Okay, whatever the value here, you just put it here. Okay, it will be what is the value? So e to the power sum of e to the power minus er. I am putting this equation. Okay, you can put this directly also. You can put this because psi naught plus half is cos omega. I put as a alpha. Okay, then it will be alpha plus n is cos omega into beta. Is it okay? Similarly here also sum of alpha plus n is cos omega e to the power minus alpha plus is cos omega n into beta. Okay. this will come. What is happened? E to the power minus alpha beta is constant. I take that e to the power minus n is cos omega beta. Okay. Now this part is, I can separate it out. Alpha e to the power minus alpha beta, okay, into e to the power minus n is cos omega beta, okay, plus this part n is cos omega beta e to the power minus alpha. You can, and no need to expand first of all, okay. So this is a what? This is like that a plus beta divided by c. Okay, you can expand a divided by c plus b by c. You can expand like this. So this is what? A, this is b, this is suppose c. So this part divided by this part plus this part. Okay. Release this part. So it will be sum of e to the power minus alpha beta e to the power minus n is cos omega beta. Then it will be alpha e to the power minus alpha, same I am putting alpha beta e to the power minus n is cos omega beta, plus summation e to the power minus alpha beta e to the power minus n is cos omega beta. Then it will be n is cos omega beta e to the power minus alpha plus n is cos omega beta. Okay, this part will cancel out. So finally we are getting what? Finally we are getting mean energy equal to, first term will be alpha. Okay, so next term will be e to the power alpha cancel out. Next term will be n is cos omega e to the power minus n is cos omega beta divided by summation is there, summation e to the power minus n is cos omega beta. Okay. This is the formula. So this what we understand, because what about the constant? Suppose if it is alpha plus n beta, so this part will remain same. So not to do that. Only you have to calculate the mean energy of this part and add with alpha. So what we are getting? So alpha will not change. Any constant, alpha is a constant. So alpha plus, this is I can write sum of x to the power n, okay, and this is cos omega is constant. I can n x to the power n. That calculation I have shown in a black utilization. See, e to the power minus is cos omega beta to the power n equal to this one, right? E to the power minus n is cos omega beta. Is it okay? So this equal to x to the power. This part I am considering x. Okay. So that is why alpha plus is cos omega beta. It will be what? 1 plus x square plus dot 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 dot. Similarly here first term is 0, second x plus twice x square plus thrice x cube plus blah blah blah. So this is what in binomial theorem we have learned about binomial theorem. You know this binomial theorem x to the power n 1 plus x to the power minus n. This formula you have already learned in SS. So if you check this is 1 plus x square. This is a series of binomial equation. Alpha plus is cos omega e to the power 1 minus x minus 1. Okay, and this is what? X 1 minus x minus 2. Okay, this is equal to alpha plus x, this is cancelled, x is cos omega 1 minus x. So finally we are getting mean energy alpha plus is cos omega e to the power minus H cos omega beta and 1 minus e to the power minus H cos omega beta. Okay. Equal to alpha plus H cos omega 1 minus e to the power minus H cos omega beta minus 1, or you can express alpha plus H cos omega e to the power H cos omega by kt minus 1. Okay, this is part of the similar to the black body radiation. Okay, this is due to phonon, but in the previous lecture I have told you the how can you calculate mean energy, how can you calculate the average number of photon in black body radiation. But in phonon also, phonon is also boson, so it follow the same rule, and the mathematical function is same, expression is same, and result is also same. Only number one is called phonon, one is called photon. This is expression phonon. This expression is very essential in order to explain Einstein photoelectric effect and Debye Pacific. Einstein Pacific theory, Einstein and Debye Pacific theory. Okay, I will discuss in the later. That is why I am showing here. Okay, and next, suppose if I say, now can you say what happened if I say energy of a system is equal to suppose alpha plus n is cos omega. Okay, then the average energy will be this one is alpha remains same, and then next part you have to H cos omega bracket average number. Okay, this is the average number. Average energy alpha is a constant, you cannot take the average, it will become out H cos omega is constant, so you have to take the average number of particles. So average number of particles, how can you calculate? So it is very easy. Suppose I am using the mean energy formula. Okay, now I have derived this relation. Finally I got this relation. Mean energy. I am getting alpha plus H cos omega e to the power H cos omega by kt minus 1. Okay, I am getting this value, so I can find out this value using the mean number of particles. Okay, how can you see? According to this is the formula, this is the energy of the system, mean energy alpha you cannot take the mean, and H cos omega cannot take the mean, so you have to take the mean of number of particles or number of phonon. So how can you calculate now mean number of phonon? Formula is same, beta is equal to ER. When n is there, then you have to put n. Okay, e to the power minus beta ER. This is the formula. In previous step, I have written mean energy ER. So that is why I put ER or E. Now I am putting mean number of particles, so I have to put mean n. Okay, this arbitrary, suppose this is arbitrary value A, operator A, then you have to put A. Okay, same way we have to calculate. Then it is very easy, this is very easy, you just put the value n e to the power minus n is cos omega beta e to the power minus n is cos omega beta, so it will be same, n x to the power n x to the power same formula. So it will give you x 1 minus x, so it will be x means 1 e to the power is cos omega beta kt minus 1. It's very easy. Okay, now if I ask you the question, suppose it is the harmonic oscillator, n plus half H cos. Now question again. In exam, what type of question is often given? Consider a system of harmonic oscillator. Calculate the mean energy of the system without considering the 0 point energy. If the question is like that, what is the 0 point energy? This part. Half H cos omega is 0 point energy. Okay. Minimum energy is which is known as the 0 point energy for n equal to 0. If the question is like that, then you remove this part. Only you have to consider n is cos omega. Okay, if 0 point energy is excluded. If it is 0 point energy is not excluded, Then what is the 0 point energy? Half h cos omega plus n h cos omega. What I am saying, in previous lecture, this is alpha plus n h cos omega. So no need to change anything. Just what is the mean energy? Mean energy half h cos omega will be there plus h cos omega into mean number. No need to do anything this part. Okay. If 0 point energy is excluded, then this part will be 0. If it is not excluded, then this part will be added. This is a mean energy. But whenever you go for the passive heat calculation, what is the passive heat formula? CV equal to du by dt. Or here I am mean energy is written as E, so dE by dt. So if you take the dE by dt mean energy, so this part is constant 0, and you have to take this mean energy only depend on second part. So what does it mean that even it is if you consider 0 point energy, or you may not consider 0 point energy, specific it does not depend on this constant value, only this variable term. So I will show whenever we discuss the Debye and Einstein theory in statistical viewpoint. You can easily understand. Okay, but right now I am not going to start because I have to give some general formula. The general formula is very, very important. Suppose for density of function, density of state. Often I encounter many students who never understand what do you mean by density of state. What is the general formula? So first of all, I will clear the density of function, or in statistical view it is called number of microstate, or you can say mode of vibration. So I will give the general formula for that. General formula means it will valid for 2D, it will valid for 3D, and it will this density of state function is always depend on the dispersion relation and dimension of the geometrical dimension. Okay, that is why I will give a general formula. Using the general formula, you can derive all easily without doing any calculation. So I will give the general formula, then I will move to the Einstein and Debye theory, passive in statistical. Then you no need to study in condensed matter physics. Okay. Now this is where you have to calculate the mean energy. Now in exam I have seen many one question, that is a fluctuation of energy, which is also known as a variance and also known as a standard deviation or RMS value. So how to calculate the energy fluctuation? So energy fluctuation. So energy fluctuation, how to calculate? See, this is suppose mean energy. Mean energy formula I have already told you. Okay, I can use U also. Okay, you can use E also, no problem. Use. Only you have to understand what is U. U means internal energy. If you confuse, you replace E. Okay, I am not writing this symbol. Simply put the abbreviation. U, you can put E, no problem. You can put this symbol also, mathematical mean value symbol. Okay. Now what happened? How to now I have to do du by dt. This is given in an exam. Why I am doing this, I will tell you later. So this will equal to derivative. This is the first term with respect to beta. This is a constant term. This is one term is this one term is this. It is suppose a by b. Okay, a by b form. You can do like this, a beta inverse. You can put like this also. Then take the derivative. So I am not going to do that. Probably you will understand. So this is beta here. I am not doing the derivative this part. This is suppose beta part. I am taking the derivative of a part. So ER is constant. It will come out derivative of e to the power minus beta ER. Is it okay? Next term I will do second. ER is also constant. E to the power minus beta ER. It will come out derivative of z e to the power minus beta ER to the power minus 1. Is it okay right now? So it will give what? It will give what? Sum of e to the power minus beta ER and ER square e to the power minus beta ER. First term. Second term will give you what? E to minus will come out. It will be square ER e to the power minus beta ER minus 1, then Z e to the power minus beta ER minus 2, then del beta by e to the power minus beta ER. Is it okay? So this is what I have already shown you. X square mean value, it will be like that. Any arbitrary mean value of any arbitrary parameter, e to the power minus beta ER e to the power minus beta ER. Is it okay? Now it is energy, so it will be what? Is it okay? And this term, if you solve it, it will be like this. E to the power minus, you can check it, no problem. ER e to the power minus beta ER to the power square. If you solve it, okay. Finally, you are getting minus E square plus E square. So what we understand, del U by del beta equal to, or you can E also, no problem, E also, you can write E also, okay? Don't confuse. Del U by del beta minus E square plus E square. I am getting this form. This question comes in a gate exam as well as net exam. That's why I have shown you the derivation, how to derive. Now, can you remember this formula? Del x square equal to x square minus of x. This is, can you remember this formula? This is what? Square. This is what? This is known as a variance. Okay? And if you remove the square, if you take the square root, then it will be standard deviation or called RMS value. RMS, or here it will be RMS fluctuation. So that is why I can write minus del U by del beta equal to E square minus E square. Okay, this is what del E square. This question comes in a gate exam, net exam. How they given, I will discuss later. First of all, then del E square, this is RMS fluctuation. Always remember, this is RMS fluctuation equal to minus del U by del beta. So, what in an exam asks, in exam question is like that, which of the following statement is correct? The fluctuation of energy is proportional to T, proportional to specific heat, or proportional to order of T is what, like that. So this is the fluctuation. So now you have to calculate the fluctuation of energy. This is a RMS value equal to minus del U by del beta. Now I have to express in beta in terms of KT, 1 by KT or T. Then I can calculate the specific heat. That is why beta equal to 1 by KT. Okay, del beta equal to minus of 1 by KT square. Okay, dt. Or you can partially empty, no problem. Then it will be KT square du by dt. Okay, that means it will be plus, it will be KT square into specific. That means RMS fluctuation del E is proportional to T1 and CV half. This question comes in an exam. Okay. This is RMS fluctuation proportional to T. Okay. Sometimes what happens, energy will be given. Okay. And you have to calculate the fluctuation of energy from the internal energy or mean energy. It is easy, only take the derivative of mean energy. This is the formula. If you forget, it is a two-step calculation. You can do in an exam hall itself. Okay. Now I will go to the statistical function. Statistical function. What are the statistical function? In thermodynamics, in statistics, there is a three important system. One is microcanonical, one is microcanonical, canonical. Two is grand canonical. Canonical. Three is grand canonical. Canonical system. This is microcanonical. EVN. This is TVN and TV mu. This is not it. This three thermodynamical system we have to study. One is microcanonical, is smallest system. Micro means small. So EVN it depends on energy, volume, number of particles. Function of this three variable. And canonical system TVN, temperature, volume, number of particles. EVN, TVN, TV mu. Canonical, temperature, volume, and chemical potential. Okay, chemical potential means energy. Or at T equal to 0 Kelvin, chemical potential become Fermi energy. Okay. Now, most important system is this one. Question is often comes the canonical system. Okay. That is why now we have to give more focus on the canonical system. TVM, temperature, volume, and number of particles. So I will discuss first canonical system. Canonical system first. Canonical system. TVM. Temperature, volume, number of particles is variable. This function is is a function of temperature, volume, and number of particles. So first of all, I will derive the relation, but you focus on this board because the parameter evaluation of thermodynamical parameter evaluation does not depend on how much you can memorize. Okay, only learn the tricks. So if you forget, suppose if you forget the expression of potential, pressure, or entropy, or chemical potential, how can you calculate easily? That's what I am going to give you. So you know this. A is represent free energy, U minus Ts. Have you remembered this formula? A is the free energy, U is the internal energy, T is temperature, S is entropy. These are the parameters. Okay. But in canonical system, this is now we have to add another term. This is a normally we know, and another term chemical potential N. Okay. This formula A equal to A is represent free energy. You can express F also in some book. U minus Ts plus mu n. Okay. So in exam, what type of question I will learn? dA equal to what is the value? du minus Tds minus S dt. Derivative, just derivative. And mu is constant. We cannot take that. This. Okay. Mu is constant. So only here mu is not there. Mu is constant. So that is why mu is only one time mu. Simple differentiation. Differentiation is DAB. How can you do differentiation? DAB plus BDA. Okay. Similarly differentiation. Okay. Now from the du, for the first thermodynamical relation, dq equal to what? Du plus pv. This is a thermodynamical relations. So dq means what? TDS. dq means TDS equal to du plus pdv. So replace this value here. TDS minus pdv minus TDS minus SDT minus or plus mu dm. So why I am showing this derivation? There is a two important fact. I want to show TDS cancel. Minus pdv will be here. Minus SDT plus mu dm. Okay. So this equation means verify that A is a free energy of the system is function of here. What is it? dV function of V. Here dt function of T and function of n. That means it is clear. That means a is a function. A is depend on v t n. Okay, it is verified. Suppose if you confuse whether it is tvn or tv mu and tvn in example, you just remember this formula, take the derivative, and finally which derivative term is remaining. Here dv is there, dt is there, so dn is there. That means a is a function of v t n. Okay, you can remember this way also. I have already written in the above. But even if you forget, if somebody asks you or in an exam, which of the following statement is correct? So how can you identify? You can identify easily. Okay. Now finally I derive dA equal to minus p dv minus s dt plus mu dn. This is the relation. Okay. This is dv, this is dt, dt. That is why A is a function of v t n. Okay. This is how we can identify. Number one, I have to calculate from here. What are the parameters I can calculate from the partition function of free energy? P S U. P S U. Can you calculate? So if I take the P, what is the pressure? dA by P equal to dA by dV. dA equal to dV. If temperature is constant, dN is constant. Okay. Temperature constant and n is constant. Why? Because if the temperature is constant, dt is 0, derivative of constant is 0. If n is constant, number of particles is constant, then dn is 0. Then E is this one. So, and S is equal to, similarly S is equal to dA by dt, V constant, n constant. Okay. Similarly, chemical potential equal to dA by dN, constant V and T. This is the problem. In exam, I have seen the question paper of GATE net exam. Okay, I have seen the question, which of the following statement is correct? They will give this type of expression, and you correct form of this expression you have to find out. Only remember the free energy formula and take the derivative. After that, using this way, you will have to calculate the parameter, and you can easily find out the correct answer. Okay. And that is one way. Second way is that in sometime what happen, free energy in the question will be given. Okay. Suppose free energy of a thermodynamical system of T energy system is given, is suppose this one. Free energy is given as 1 plus e to the minus beta e. Suppose then beta e or something like that. Then you have to calculate pressure, dA by dt. Entropy you can calculate with respect to T. Okay. And chemical potential you can calculate, but here not n is not there, so it will be 0. Pressure is 0 in this case, but then entropy will not be 0. Okay, this is why this is important. No need to memorize this thing. Only remember the free energy formula, A equal to U minus Ts plus mu n. Okay. Now I will discuss the free energy. Now you can say what do you mean by free energy of a system? So free energy of a system is energy available in the system which is not used. Okay, free energy means free energy available in the system and which is not used. Okay, we always try to minimize the free energy, because if I have more energy in my body, I will be excited that I want to push somewhere. Similarly, in the universal process, if we want to make the system stable, we have to minimize the energy. Suppose this is general formula. I am writing U minus Ts. I am not writing dot this side U and the. Simple, we have understood. Okay. So free energy means, suppose this is entropy. In order to reduce the free energy, what we have to increase? We have to increase the entropy. Entropy means disorderness. If we increase the disorderness, then what happens? This is a minus term, free energy will be less, and in that case, the material or system is more stable. Okay. whatever doing in কমাখালা দেখিছে নাই দা বনাইছে দাটো কি হয় ফ্ৰী এনাৰ্জিটো পুৰা দাটো পুৰা চেপ দি পেলাই পানীত ভৰাই দিয়ে যে when you heat this particular knife then entropy will gradually becomes very high. Disorderness of particles become very high, and after that it suddenly drop in a water, so that and disorderness remains same, become very high, and it never cool down to the ground state. If it is come to the ground state, normal state, lahe jodi temperature to komi ahi thake, tete ki hobo, then entropy will gradually decrease and it will be ideal state. Then again free energy will be high. So that is why we always দাখন গৰম কৰাৰ পিছত হিট কৰাৰ পিছত পানীত ভৰাই দিওঁ যাতে এন্ট্ৰপিটো সমানে হৈ থাকে, তেতিয়া ফ্ৰী এনাৰ্জিটো কমি যায় আৰু দাখন ষ্টেবল হয়। সেইটো কৰে কমাখাল। অ'কে, now you see internal energy we can write A minus ds. Yes, I am not writing with n is constant. Okay, we simplify the formula. Then A equal to dt. S means what? I have already given you dA by dt. Okay, dA by dt from where get A equal to u minus ds plus mu n, dA equal to du means tds minus pdv minus s dt plus mu dn. This gets cancel, pdv minus s dt plus mu dn. Okay, so S equal to entropy, I can put it here like this. Okay, I will make them A equal to u minus ds. Okay, yes, u internal, I want to find out the internal energy from free energy. How can I calculate? Yes, A minus dA by dt. Can I write like this? Because from this, so I can eat this expression, I can reduce this term. If you see this dt A by t, with this form, if you reduce it, if you expand, you will get this value. This is A, this is B, T is B suppose, and then I can expand d by d 1 by t d A by t. Okay, then I can expand d A by kt d 1 by kt equal to 1 by kt means beta, A beta, then d beta. Okay, why I am doing this, I will tell you later. So finally what we are getting, internal energy, that is the mean energy, equal to dA beta d beta. Okay, this formula, but this is one equation, but we know mean energy formula is this one, e to the power minus beta here. I am writing here u. Okay, no problem, don't confuse, u e same mean energy, so er e to the power minus beta here. Okay, so it will be what? Minus, I have already told you, d by dt ln z. Is it okay? This derivation of this term I have already shown you. If you take the ln z, again I am showing you, if you confuse, this is what? This is z, this is er e to the power minus beta er. So I can write this is d by d beta ln z. Ln z, if you take derivative ln z of derivative of ln z with respect to beta equal to what? 1 by z d by d beta z. Z means this one. If you take the derivative, you will get this expression. I have in the previous video I have shown you how. So we simply write this expression is a del beta ln z. So this is equation 2. In form 1 and 2, what do we get? Del a beta by del beta equal to minus of d by d beta ln on z. Okay. So this will I remove. Okay, no problem. D beta. So in the next step, what I can, because this is what d beta. So a beta equal to minus of ln z. Okay. Beta means what? 1 by kt. So free energy equal to minus kt ln z. Remember this formula. Now what we are getting, free energy of a system is equal to kt ln z. This is very, very important in exam. So how can you calculate? There is internal energy I have shown you. Free energy of the system in terms of internal U minus ds plus mu1 I have shown you. And from that formula you can calculate entropy, pressure, volume and chemical potential I have shown you. And now free energy formula equal to U, A equal to kt ln z. Z is a partition function. Okay. Suppose in exam question is given in terms of energy level, and from that energy level you have to calculate partition function. From the partition function you can calculate what? You can calculate probability, you can calculate mean energy, you can calculate free energy. Okay. Now slowly I am going to the thermodynamical problem. Now one or two problem, if you do it problem, then you can understand easily. Now I am not going to write the question. Consider a 3 particle system. Okay, consider system 3 particle. 1 particle, 2 particle, 3 particle. Okay, you try to understand the question. Consider a system of 3 particle. Each particle has 3 energy level. Each particle has 3 energy level. 0 energy, 3 energy level. Okay, 0 E twice. Okay, and this energy E state is doubly degenerate. Doubly degenerate. Means GR equal to 2 here. Okay, here GR equal to 1, here GR equal to 1. Consider a system of 3 particles. Each particle has 3 energy level, 0 E twice E, and energy level 2 is doubly degenerate. Okay, now you listen the question. Find the partition function for single particle n of the system. First of all, partition function, calculate z for one particle. Then for whole system. Okay, partition function you first of all you calculate for single particle. Then you have to calculate for 3 particular system. Whole system you have to calculate. Next question. And next z for same condition, z for distinguishable and indistinguishable particle. Now question is that you have to find out the partition function for a single particle and for the whole system. Number 1 question. Next question is calculate the partition function if considering the system. First you considering the system, each particle in the system is distinguishable, and next calculate the partition function for each particle considering that this particle is indistinguishable. Okay, 2 questions. Number 3 question, find the mean energy. Third question is that find mean energy. Mean energy calculate using mu equal to minus d by d beta ln z. First ln z you have to calculate. Second calculation is that secondly and you have to calculate mean energy from ER PR probability theory. Can you calculate? Okay, we understand the question. First of all, I will find out the partition function. 3 particular system. Again, I am drawing for clear understanding. I am drawing here particle 1, particle 2, particle 3. Each particle has T energy level. This is 0, this is E, this is twice E, and this level Gr equal to 2, this is Gr equal to 1, this is Gr equal to 1. That means the system is, first of all you have to understand this system is degenerate system. Okay, so what is the formula of degenerate partition function of degenerate system? Gr e to the power minus beta E. Okay, this is R's number of step, number of microstep is 1, 2, 3. Okay, first is 1 is 1, this energy e to the power minus 0, energy is 0. Next step is 2, Gr equal to 2 into e to the power minus beta E. Okay, next step is e to the power is 1, e to the power minus 2 beta E. Okay, this is 1, this is twice e to the power minus beta E plus e to the power minus 2 beta E. We can simply write 1 plus e to the power minus beta E squared. Is it okay? A plus b whole square. This is the partition function for single particle. Do not confuse. Okay. So now partition function. Partition function I get 1 plus e to the power minus beta E square. Okay. This is for single particle, for one particle. For whole system. Whole system, how can you calculate? So z equal to z to the power n. Okay. For, you see, for indistinguishable particle, this is formula. And for indistinguishable particle, z to the power n factorial n. Okay, indistinguishable particle. So it will be what? 1 plus e to the power minus beta E square into n number of particle. N means number of particle. It will be 3. Okay, you can expand. It will be 1 plus e to the power beta E 6. It will become 6. Okay. This case, it will be, this is what? 1 plus e to the power minus beta E 6 divided by 3 factorial 3 particle. Okay, this is for indistinguishable, this is for distinguishable. Do not confuse. Now you have to calculate mean energy from partition function. Now you may confuse whether I will calculate mean energy from this value or this value. For single particles partition function or whole particle partition function only I have to calculate. Okay, you can calculate from here also. You have to calculate. You can calculate from here also. But in this case, what happened? I will show you. Then you will never confuse with any problem. Okay, I will calculate LNZ. What is the LNZ? Because I have in the question it is given that. In the question it is there. You calculate. You have to calculate from this formula. It is easy. That is why they have asked you. And n equal to sum of ER into beta. Beta no. PR probability. You have to calculate from probability. So how can you calculate? This is Z. I will calculate from single particle partition function. You always try to evaluate the mean energy from single particle partition function. Okay. If you find out the total energy, then mean energy into number of particles, you product it at the last test. Okay. So LNZ equal to I can directly prove. Okay, no problem. You can easily understand. It is simple calculation. Del beta 2 will come out. LNZ 2 ln 1 plus e to the power minus beta E. This is the formula. So if I take the derivative of this, minus 2 is there. It will what? 1 plus e to the power minus beta E. Then derivative of d beta 1 plus e to the power minus beta E. It will be 1 plus e to the power minus beta E. Okay. Then it will be 0. It will beta E will come out. Then minus 2e e to the power minus beta E. It is the mean energy. Okay. And what happens if you calculate the mean energy from this? Suppose if you calculate this is the total mean partition function. 1 plus e to the power minus beta E square into TS, total partition function of the whole system. T, why T? This to the power n. N is the number of particles. Here there is a T particle, that's why it is T. So it will be e to the power beta e 6. Okay. So if okay, you got this value. Okay, this is simple, and I want to calculate from here what happened here. D beta 6 will come out, and rest of the thing 1 plus e to the power minus beta e. Here you are getting how much? 2e to the power minus beta e 1 plus e to the power minus beta e. Only difference 6 is coming out. That means what? You are getting, you will get 6 into e to the power minus beta e 1 plus e to the power minus beta e. Okay? So result is different. Why? Because here number of particles is producted. Then what you have to do, you by T particle you have to take it out. T particle means whole system is consisting of T particle, that is average. Now it will represent the average mean energy. It will be 2e to the power minus beta e to the power minus beta e. So if you do from here, but do not forget to divide by the number of particles. Both sides you divide by the number of particles. This is mean energy. Now if you product by T number of particles into number of particles, then you will get the total energy. That's what I am getting here, total energy. Okay. Now second question from where I have to calculate. Second question is that I have to calculate the mean energy using this formula. So I have to calculate how many number of microsteps. T step 0, 0, E twice step. So 0, 2, 1, 1. This is the step. So this means what? Mean energy in this is E1, P1, E2, P2 plus ET, PT. Okay. Here E1 means 0 into P1. ET is E, P2. This is a twice E, PT. So this is 0, E1, P1, P2, so P2 step plus twice E, PT step. That means what? P1 and P2 and PT you have to calculate. What is the probability formula? PR equal to probability formula ZR e to the power, this is probability for degenerate system. Okay, ZR e to the power minus beta E. Now what is the probability I have to find out? State 2 and state 3 probability calculate. P2 means this step. So degeneracy how much? Degeneracy 2 e to the power minus beta E. Okay. Here this is 0. First one is 0. 1 into e to the power minus beta E. Is it okay? Second step 2 into e to the power minus beta E. Okay. Third step 1 into e to the power minus beta 2 beta E. That is probability P2. Probably you are getting first term is 0, 1 plus beta E to the power minus beta E square. Okay. 2 e to the power minus beta E. Okay. P2 I am getting this one. So what is the value of P1? What is the value of PT? PT means energy state T. Energy state T e to the power degeneracy 1 into e to the power 2 beta E. Okay. And denominator will remain same, 1 plus e to the power minus beta E square. Okay. Is it? So you put this value E into first P2, what I am getting? 2 into e to the power minus beta E 1 plus e to the power minus beta E square plus 2e into this one e to the power minus twice beta E 1 plus e to the power minus beta E square. Clear? Equal to how much? Twice E common, equal to twice E common, e to the power minus beta E, I take it out, 1 plus e to the power minus beta E common, 1 plus e to the power minus beta E square. So 1 cancel out. So finally I am getting what? Twice e to the power minus beta e, 1 plus e to the power minus beta e. Okay, I am getting same result. And initially what using this formula, what I am getting using this formula, d beta ln z, I am getting 2e e to the power minus beta e and 1 plus e to the power minus beta e. We are getting same result. You check it. Okay, this is where we have to calculate. So time is over. I think I have to stop here, and next time I will discuss more numerical problem, and in the meantime I will give the formula how to remember. Okay, then it will be easy to understand. Thank you.